In the silent darkness of space, the James Webb Space Telescope opened its golden eye. For 120 hours, it stared into a patch of sky that once seemed empty. It gathered ancient photons, light that travelled billions of years to reach us. The resulting image is a deep field overflowing with galaxies. But these galaxies are not what we expected. They are too old, too large, and too well formed for their place in the early universe. Imagine finding a fully grown adult in a nursery of newborns. This single photograph has ignited a firestorm in the scientific community. The data is solid, no error, no mistake. The universe itself is presenting us with a paradox. We must now reconcile what we see with what we believe. These galaxies are ancient, seen as they were over 13 billion years ago, just a few 100 million years after the Big Bang. Our models predicted small, chaotic galaxies at this time, not massive, mature ones. Instead, Webb has shown us galaxies with spiral arms and central bulges, structures that shouldn't exist so soon. This finding defies our cosmic rulebook. The universe is more complex and mysterious than we ever imagined. This photograph is our gateway to understanding its deepest secrets. Today, we journey to the edge of time to explore a discovery that challenges everything. Welcome to Cosmic Discoveries. Let's begin. To grasp this discovery, we must revisit our expectations. The Big Bang theory tells us the universe began hot and dense, then expanded and cooled. Gravity slowly pulled together gas and dust, forming the first galaxies, supposedly small, faint and misshapen. The James Webb Telescope was built to see these cosmic toddlers. Instead, it found galaxies that looked like teenagers, massive, organized and mature. The timeline doesn't add up. Scientists expected to find primitive cosmic huts, but instead found fully constructed castles. These galaxies are brimming with stars and structure, far more evolved than our models allow. Either galaxies form much faster than we thought, or the universe is older than we believe. Both possibilities shake the foundations of cosmology. According to our models, there wasn't enough matter or time for such massive structures to form so quickly. The existence of these behemoths directly contradicts the standard model. The universe is showing us that our story of its childhood may be wrong. We're forced back to the drawing board. This is cosmic archaeology at its most dramatic. Every new observation is a layer peeled back in time. The mystery deepens. What will we find next? Our understanding of the universe rests on the lambda CDM model, dark energy and cold dark matter. This model explains the cosmic microwave background, the universe's structure, and the abundance of elements. It's been our cosmic blueprint for decades. But Webb's discovery strains this foundation. The model predicts a slow, bottom-up process. Small galaxies merge over billions of years to form giants. The new galaxies break this speed limit. They're too big, too soon. This hints at a fundamental flaw in our understanding of dark matter or the process itself. Maybe dark matter isn't as cold as we thought, or perhaps there's an ingredient we've missed. Some scientists are exploring alternatives, warm dark matter or primordial black holes as seeds for rapid galaxy formation. These ideas could shift our entire cosmological paradigm. The nature of dark matter and galaxy formation is central to our own origins. The cracks in our theory aren't failures, they're signs of progress. The universe is telling us the story is more complex than we knew. We're on the verge of a deeper, more accurate reality. The search for answers has never been more urgent. The Big Bang theory describes the universe's expansion from a hot, dense state. It's the cornerstone of modern science, supported by overwhelming evidence. But Webb's findings challenge its timeline. The theory predicts when the first stars and galaxies should appear. These mature galaxies formed too quickly, grew too large, and organized themselves too neatly. It's like finding a complex civilization in the fossil record before life was supposed to exist. This doesn't mean the Big Bang is wrong, just incomplete. Perhaps early universe conditions were different, or unknown mechanisms accelerated galaxy formation. Scientists are racing to adjust their models and explore new physics. The challenge is healthy for science. When observations contradict theory, the theory must adapt. The Big Bang isn't dogma, it's a model, always open to refinement. Webb's discovery is an opportunity, not a crisis. We're being pushed to look deeper and expand our conception of the cosmos. The universe is stranger than we ever imagined. Faced with this puzzle, scientists are exploring extraordinary ideas. One is conformal cyclic cosmology, proposed by Roger Penrose. In this model, our universe is just one in a series, each born from the ashes of the last. If true, some structures from a previous universe could have survived the transition. These ancient galaxies might be relics, ghosts from a previous cosmos. It's a breathtaking idea. The Big Bang as a transition, not a beginning. Our universe could carry the memory of a parent, stretching back beyond 13.8 billion years. This is speculative, but the fact it's being discussed shows how profound Webb's discovery is. Whether these galaxies are evidence of a past universe or just a sign of rapid formation, the implications are staggering. We're peering into the dawn of time and finding hints that time itself may be more complex than we thought. In times of upheaval, we look to trusted voices like Dr. Michio Kaku. He's a renowned physicist and communicator, and his reaction to Webb's discovery was cautious excitement. Dr. Kaku likens the standard model of cosmology to a beautiful palace, now showing cracks in its foundation. You can't ignore the cracks, you must investigate. This is how science moves forward, not by proving theories right, but by testing them against new evidence. Webb is stress-testing our most cherished ideas, revealing potential weaknesses. Dr. Kaku suggests we may be on the verge of a paradigm shift, like when we moved from a geocentric to a heliocentric model. New physics may be needed to explain these observations. We could be seeing the first hints of a theory that unifies gravity and quantum mechanics, a theory of everything. Dr. Kaku urges us not to abandon the Big Bang, but to expand our thinking. Science is a journey, not a collection of unchanging facts. This is not a crisis, but a glorious opportunity. We're about to learn something profound about the universe. His calm voice cuts through the noise, encouraging us to embrace the mystery. The frontiers of knowledge are opening before our eyes. The impossible galaxies have revived our most ambitious theories. String theory, our best candidate for quantum gravity, suggests the universe is made of vibrating strings and predicts other dimensions. The multiverse emerges from these ideas, our universe as one bubble among countless others. Perhaps our universe collided with another, seeding rapid galaxy formation. It's a wild idea, but Webb's data gives it new weight. Another path is rethinking gravity itself. Einstein's theory is incomplete at extremes. A theory of quantum gravity might reveal new mechanisms for fast structure formation. These theories, string theory, the multiverse, quantum gravity, are at the frontier of human thought. Webb may have provided the first observational clue. Theorists now have a concrete problem to solve. The answer could rewrite our understanding of space, time, and reality. The race is on. We stand at a turning point in science. One image from Webb has challenged our deepest assumptions. The discovery of these ancient, massive galaxies is not the end. It's the beginning of a new story. This is the essence of exploration, venturing into the unknown, ready to be surprised. For every answer, new questions emerge. Scientists worldwide are now working with renewed purpose, developing new theories and pushing boundaries. The puzzle of these galaxies is one of the greatest mysteries of our time. Solving it could revolutionize our understanding of the universe. We may discover a multiverse, secrets before the Big Bang, or a unified theory of everything. Whatever the answer, it will be more wonderful and strange than we can imagine. The universe invites us to solve its greatest riddle. Thank you for joining us on this journey through cosmic discoveries. The adventure is just beginning.